So business statistics unit number 5. In unit number 5, we're going to be talking about variability. So in this unit, what is the most important for you to learn is the concept of standard deviation. The concept of standard deviation is very critical because we're going to be using it in many things in many of the units. So let's go very quickly to the standard deviation. So the standard deviation is a number that summarizes how far away from the average the data values typically are. So let's say we have a line, and in that line we have biggest value is 10, lowest value is 0, and then we say we have the average is 5. Okay, so how far are gonna be the numbers out of that? Maybe I have some numbers in there. Okay, so here the variability is wide. Okay, you can see that not all the numbers are closer to the average. So what happens in this case? The data might be skewed. Okay, that can be, if there's many numbers on this side, then of course then it's gonna be an issue in there. So what we're trying to look at, the standard deviation, is, again, for example, like I said, is a summary of how far those numbers are in average. Okay, so let's say, for example, I have here 5, and I have many numbers are very near to the average. Okay, that's gonna make us a very nice distribution, normal distribution. And then in this case we can see that, for example, here the standard deviation is gonna be very low. Why? Because the numbers are too close to it. So let's look at an example here for me to illustrate this is in a very easy way. Okay, let me pass myself, let me fly there to the bottom, because otherwise you cannot see. So in this case, for example, see, we have numbers 1.3, 1.3, 1.3, and 1.3. What is the average? 1.3. So the standard deviation is going to be 0. Why? Because here we have that all the values are in 1.3. Okay, so there's no distance because everybody is already here, 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 here. So there's 0. Now, when we look, again, focus on this one, the average is 1.3. And the standard deviation is 0 because they are all located in there. Now, in this case, we have another data set. In this data set, the numbers are going to be scattered throughout. So there's going to be like here 2.6, then somewhere here minus 14.2. Okay, then on this side is gonna be 11.4, and then here is gonna be maybe 5.4. Okay, what is the average? The average is still 1.3. 1.3. Okay, the problem is that the numbers are way too far. So the standard deviation here is 10.97. That means on average all the numbers are 10 numbers away from the 1.3. Okay, so all of them do an average. So let's go, and why don't we do just an average? And I'm going to explain you to do this very clearly on the following example. Let me fly into the top. Woo! So now we have, for example, in this case, the data values that we were speaking about now, and how this standard deviation is calculated. So in this case, first of all, what we have is, here we have it, sorry, 2.6 minus 14.2, 11.4, 5.4. We add them, it gives us 5.2, and the average is 1.3. So now, what we do to calculate the deviations, not the standard deviation, just the deviation for each one of them. Each one of them, how far is from the average. So again, the average, as I have it in here, the average is 1.3. Okay, so this one, so I'm gonna have my value minus my average, and that's gonna tell me how many deviations are far away. So in this case, 2.6 is 1.3 away from 1.3. In this case, minus 4.2 is minus 15.5 numbers away from 1.3. 11.4 is going to be 10.1 numbers away from 1.3, and so on. Also, this number is going to be 4.1 numbers away from 130. Okay? So, these are the deviations for each one of the numbers. Means how far away is each number from the average. Okay? The average is 1.3. But what happens if I add them all? Why not just add them and then that's it? Then I get to know how much is that, because it's gonna give me 0. Okay. So what we have to do is square each one of them. So 1.3 times 1.3, 15.5 times 15.5, 10.1 times 10.1, and 4.1 times 4.1, and that's gonna give us this result. These are the deviations squared. Why do we need to square them? In order to avoid this 0. Okay? Because if you realize here we have a negative, for example, and that becomes positive. Okay? So that becomes already the deviations squared. That's the result of the deviation squared. Now in here what happens is that if we add them and we divide them by the sum, we have the variance. This is the variance now. The variance, we're not going to use it because it's a very large number. I cannot be 120 numbers away. It's impossible to have that number because even the largest number was 11.4. Well, sorry, the largest number was 14.2. Right, so in this case, because I cannot do that even if I divide them, what I have to do is square root it again. Remember, in this one, some basic math. In this one, I am squaring, okay? And then in this case, I have to root this number. Then when I root this number, then what happens here is that I have the 10.97, which is the standard deviation. That means, on average, like I said, there are some numbers that have very little deviation. But there's a number that has a very large deviation. Why? Because this data is too scattered. The average, or this standard deviation, is very high, 10.97. You're going to say like, Professor, but this one is very near. Yeah, but this one is very far. So again, it's causing too much noise, and that's a problem with that. Okay, very good. So now let's go to my initial menu. Okay. Very good. So like I was saying, in this case we have that standard deviations in a normal distribution. So how many standard deviations we have in a normal distribution? So let me see where I have it here, because in this one is much clearer. This one is easier, is better. Okay. So now we have, for example, that how many standard deviations we're gonna find in a normal distribution. This is important to know because we're gonna realize in a standard, let's say for example, again, in that case, in a normal distribution, there's gonna be one standard deviation. In this case, for example, that distribution was not standard, but in this case, for example, or the other one, 2/3 of the data are gonna be located in here. Okay. Meaning, for example, if I have 5 plus 6 plus 4 plus 7, okay, in this case I have 4, then 15, 20, 22, okay, that's 22. So that means if I calculate the standard deviation of this one, Majority of the data is gonna be, let's say for example, if the average in that specific case is let's say the average is 5 and the standard deviation is, let's say, maybe around 2.5. Okay, in that example that I mentioned just now. So in this case, like say for example, this is number 5, this is 5, then this is 2.5, this is another 2.5, and this is one more 2.5. Okay, so that means 7.5, 10, 12.5. So majority of the data is gonna be already 2/3 of the data are gonna be here. From that range of numbers that I gave you, like 6, 7, 2, sorry, 4, 4, 6, 7, 4, 6, 7, all those numbers are within here. Okay. In that case, I didn't have any numbers in 2 standard deviations, and I didn't have any numbers in 2 and 3 standard deviations. Okay. So that means my data was normally distributed in that example. Of course, I didn't calculate it correctly, accurately, but I did as much as I could. So like I said, in this case, we have to see because most of the data is gonna be here, and then later we could use that because when we start to go into the direction of how variability affects our data set, then the problem is that if the data is too far, then it's not reliable data. But that one we will watch it later. Okay, so anyways, the important thing that you have to know in here is that we have majority of the data is within 1 or maximum 2. Already 3, almost not there, but still everything is within 3 on a normal distribution. Okay, most of the data is gonna be here. Most, a little bit there, and almost nothing there. All right, very good. So now we have standard deviation in a skew distribution. Like I said, in this case, the problem, skew distribution always causes a problem, and there's no rule giving us what percentage of the data is in this distribution. That's why we always have to normalize the data, and we already explained that on the previous unit. Why? Because in this case, one standard deviation is here, but in this case there's 2 standard deviations, there's 3 standard deviations, but in this side there's only 1. So that means we cannot do that calculation, and we cannot say how accurate is that. Like I said, in the future we're looking at what's called the levels of confidence. The levels of confidence means that I believe that 95% I'm accurate that the data is there, right? That's gonna happen likelihood in 95% or 99.7%, but that's going to be in the future. But in this case, like I said, when we have skewed distributions, we cannot do such thing, and that's why we need to transform the data and make it a normal distribution. Okay, so now we have the sample population and the standard in standard deviations. We have two types. We have sample and the population. Very simple. When we have very small sets of numbers, we use the sample standard deviation, and when we have large sets of number, we have the population standard deviation. This one will be used in Excel. We have those formulas later. We're gonna go through that and we're gonna check that. Okay, just remember that smaller sets of numbers, sample, larger sets population. Why? Because there can be some changes into the standard deviation. It can increment to high if we are using the wrong one for the wrong data set. Simple as that. Okay, very good. In our case, we're gonna be almost using all the time population because we will be using very large data sets. Now we have the range. The range is very useless because in the end, for example, it's just a very simple calculation. It's the largest number minus the smallest number. So it's gonna tell us the distance between the numbers. That is not good, it's very useless. People used to do, when there were no mathematical technology before, they used to do this to calculate the range. The problem is that, to calculate the spread, the problem is that it's very sensible to outliers. If there's a very, like, let's say for example, we have a lot of numbers within here, and there's a very large number on the other side, what's going to happen is makes a lot of noise, and then the range quickly changes, and that is completely useless. So that's why we don't use it at all. We're not going to be using the range. Just remember, is the largest number minus the smallest number, and that gives us the spread. What is the spread? Is all the numbers that are in here. Okay, very good. So now let's continue to the next topic. So now we have a coefficient of variation. The coefficient of variation is just very simple. It's that standard deviation but measured in a percentage. So in this case, let's say for example, we have a customer trip to supermarket is 35.6. Standard deviation is 14, so we're gonna do that. So we're gonna see in this case, then the coefficient of variation is 14, which is the standard deviation, divided by the average, and then we're going to have is 39. So this, in this case, just the coefficient of variation is that variability measured in percentage is 39%. Remember earlier on my slides I was mentioning example, or let me do it in the other way, because if not, it's going to take me some time. Remember in this example I was calculating here the deviations, how far away. So that one is just the coefficient of variation is just this one symbolized in percentage, how much it is, right? So how far is each one of them in terms of percentage, and that's all what we calculate. Okay, very good. So good. That's it for today. If you have any questions, please do not hesitate to send me a message. Like I said, this time round, just send me Kakao messages. That is the fastest way that you can do, because if you send me through the eCampus, that email is not very good, and really takes so long for me to reply. Thank you so much, and I'll see you very, very soon.